Hi guys, good afternoon. Can you see the screen? Can you hear me?
Yes, sir.
All right, so today we're going to do a little quick session. This don't take a lot of time to go through. Very easy. It's a difference of two powers that comes under the topic of factor remainder theorem. Then we are factorizing when we have the difference of two powers. Now, let me just give a little bit of background on this, all right, and just develop this thing so we can see what the process is. Now, so at CSEC, we would have learned about the difference of two squares, which is a squared minus b squared. And we factorize this as the difference of two squared. It starts out with a minus b, and then in the bracket over a plus b. And if we were to expand it, we're going to get that back. If the power increases to 3, then what you're going to have is a cubed minus b cubed. Starts out again as a minus b. This time, since this is a cubed and this is a, first term inside there must be a squared. Then what happens is that you have, just as though you have the sum of the values here, you're going to end up having the sum of values here. So the next value is going to be a plus. The power on this will reduce, while the power on the b will start to increase. So the next term starts with a, 1 power less than that, and the b starts with a power of 1. And then you add, this power reduces to 0, a to the 0, but then the power of the b increases by 1 more to b squared. But never done, because the b times the b will give us the b cubed. And so that's done. If we increase it to 4, a to the 4th power minus b to the 4th power is a similar setup. Starts out with a minus b. And then because this is a to the 4th, the first term is going to be a cubed, because a times a to the cube is a to the 4th power. Again, the power of the a will reduce while the b will start to come up, and all the values are adding. So it becomes plus a squared b. So you see the power of the a reduced by 1 and the b is introduced. Then the a will reduce again, plus a and the b goes up by 1, b squared. Then the a finish, and then you have b cubed plus b cubed. And that's it. Then we go to the power of 5. A to the power of 5 minus b to the power of 5. You see a similar thing happening. Is a minus b you start out with. And you must have an a to the 4th power here, because a times a to the 4th power gives us a to the 5th power. And then now the power of the a is reducing, so the next one is going to be plus a cubed, and the b starts. Plus, this power reduced by 1, this power increases by 1. So you get a squared b squared. This reduces again and this increases. The next term becomes ab cubed. Then the a done, and you have the last value for the b, which is the b to the 4th power. And that's it. So far, so good? See the trend?
Yes,
so
sir.
it's not a matter of memorizing a formula, it's more a process. It's more a process. So I can choose any number, a to the 9th power minus b to the 9th power, and run the process. Equals a minus b, bracket, must be a to the 8th power, because this time this must give me the first term, a to the 9th power. Plus, all the values in here are pluses. All the values in there are pluses. I'm going to show you a little change on this just now, right? But all the values there are pluses, and the power of the a is reducing, so it goes to a to the 7th power, and the b starts. Then we continue, plus a to the 6th power, and the b increases to square, plus a to the 5th power, and the b increases to cube. What you find is happening, the powers are always adding up to 8. The powers are always adding up to 8. right? The powers are always adding up to 8. Here, the powers are always adding up to 4. Here, the powers are always adding up to 3. Here, the powers are always adding up to 2. Something like that. This continues to fall. So we'll get plus a to the 4th power, b to the 4th power, plus a cubed, b to the 5th power, plus a squared, b to the 6th power, plus a, b to the 7th power, plus b to the 8th power, and that's it. Get me?
Yes,
So far, so
sir.
good? All right. All right. Now, we can make a little bit of amendment on this when the power is odd. When the power is odd, there's an application that can be made when the power is odd. All right? So let me show you the application when the power is odd. So let me take out this one and show you, for example, when the power is odd. Like a slight adjustment that can be made when the power is odd. So you get, instead of getting the difference of 2, you can actually get the sum of 2 powers and apply this same thing when the power is odd. All right? Watch this now. Paste. I'm going to make an adjustment to this. I'm going to instead go and use, let me use a different color. I'm going to use a cubed plus b cubed. But a cubed plus b cubed is the same as a cubed minus b cubed. Agreed? Agreed?
Yes, sir.
So the difference between this and this is that instead of me having b's, I now have minus b's. So if I write by the same expansion, but I replace all my b's with a minus b, then my first term will be a minus b, bracket a squared plus a times minus b plus minus b squared. Can you see that? So it will become a plus b instead, bracket a squared, this becomes a minus ab plus a b squared. But it's basically applying the same thing when the power is odd. When the power is odd, you can have the sum of 2 powers when the power is odd and apply the difference of 2 powers application just the same. Give another example. A to the 5th power plus b to the 5th power. Because the power is odd, I can use the minus power application on it. So I'm going to write this instead as a to the 5th power minus b to the 5th power. And I use the difference of 2 powers application. Watch it now. It becomes a minus a negative b, which becomes a plus b really, bracket. I get a to the 4th power plus, this is coming down and the minus b is going up, plus a to the a cubed minus b plus a squared minus b squared plus a minus b cubed plus minus b to the 4th power. So it's me applying the same difference of 2 powers, but instead of using a b, I'm now using a minus b. So we can do the sum of 2 powers when the powers are odd using the same application because of the minus that we are able to apply. So this becomes a plus b. And the way you find an alternating of the signs inside here. Minus, plus, minus, plus. Right? So this becomes a to the 4th power minus a cubed b plus a squared b squared minus ab cubed plus b to the fourth power. So what is happening there? You get a plus here to start. We get an alternating minus, plus, minus, plus. So that's an application that can be amended with the sum of two powers. When the powers are odd, you can still apply the difference of two powers method to it. When the powers are odd, you can do the sum of two powers. When the powers are odd, apply the difference of two powers method to it, and still get a result. Okay?
Yes, sir.
Okay? All right. So let's do some questions now. So Shadi sent me some questions. And Shadi is the reason I'm actually having this class, because she asked me for help. But this is something that I intended to do in one of the Sunday classes, you know. We should have an assignment or some activity at school on Monday. So I'm just sort of fast tracking. A quick topic to do. So my plan was to do this one Sunday. But no problem in doing it now. So I'm going to look at the questions that she gave me. So she sent me some questions, and I'm going to use those questions as a sample now. Where are those questions? Let me bring them up on my phone. I'm going to write them out. All right. Hold on. Right here. Okay. So the first one she sent me was this. 16 minus x to the fourth power. Must factorize that. Write this as 2 minus x times g of x. I must find the g of x. Right? Find the g of x. This can be expressed as the difference of two powers. What is the g of x? This is the same as 2 to the fourth power minus x to the fourth power. So we use the same approach again. It's not a formula thing. It's a process thing. Don't do it as a formula. Do it as a process. The power of this is reducing while the power of this is increasing. You start out with the 2 minus x. Bracket. You need a 2 cube to start to get by the 2 to the fourth power. This will reduce while this will increase. So plus 2 squared and the x starts. Plus 2 continues to go down and the x goes up. X squared. Plus the 2 down, I have x cubed now. So this then becomes 2 bracket 2 minus x times. This is now 8. This is 4x. This is 2x squared. And this is x cubed. So this inside here so is g of x. If I want it in descending powers, I can write g of x equals x cubed first, then 2x squared, then 4x, then 8. If they want g of x in descending powers of x, you can just switch them around like that and get it. So far, so good?
Yes, sir.
All right. Then there were a couple questions to follow. All of them just need to write them as the difference of two powers. Remember, I showed the amendment for the sum of two powers. When the powers are odd, you can use the same application by introducing the minus minus. All right. So there's a question on the paper. X to the fifth power minus 243. The question is, what number is 243? Hold on a second, guys. Hold on a second. Hold on a second. All right. Back to the question. Where is it? Right. So they gave us this, and they said must write it as x minus 3 times g of x again. So we want to find g of x. So you realize that this is 3 to the 5th power. So this is really x to the 5th power minus 3 to the 5th power. So go again. Power is the same. Difference of 2 powers, x minus 3. And it's a process, it's not a formula. First value has to be x to the 4th power because these must give about the first one. Right? These must give about the first one. Then the power of this is reducing. So we're going to get x cubed, then the 3 starts, plus x squared, 3 squared, plus x 3 cubed. X done now, so then this 3 to the 4th power. Finish it. And that's it. X minus 3, bracket, x to the 4th power. This becomes 3x cubed plus 3x cubed. This becomes 9x squared plus 9x squared. This becomes 27x, 27x. And this becomes what? 81. 81. That's it. So this is g of x as a polynomial in x. So this inside there is a g of x. They ask for g of x. So far so good?
Yes, sir.
All right, let's go and do another one. That was there. These are all very easy. Do it as a process, not as a formula. So this time now we have 625 minus x to the 4th power. That looks like 5 to the 4th power. And so I must express it as 5 minus x times g of x. Again, I want to find g of x. This is 5 to the 4th power. That's what it is. So this is 5 to the 4th power minus x to the 4th power equals 5 minus x to start, bracket. This is 5 to the 4th power. You must start with 5 cubed. Because this time this must give about the first value. Alright? Must give about the first value. By the way, 5 to the 4th power is correct. 625. Look at it. Yeah, man. 25 times 25 is 625. Is this correct? Alright? Then the power of this is reducing. So you get 5 squared and the x start plus 5 and the x increase to square. Then the 5 done and you get x cubed. See? This and this. I'm going to give him the last term. And then it becomes 5 minus x bracket. This is how much? 5 cubed is how much? 125. 25 times 5 is 125 that. Plus 25x plus 5x squared plus x cubed. Done. Remember it, do it as a process, not as a formula. Next question. They want us to factorize this. 16x to the 4th minus 81. I want to express as the difference of 2 powers. I see the 4th here, so some are good. Now write this as 2 to the 4th power and write this as 3 to the 4th power. This becomes equal to 2x all to the 4th power minus 3 to the 4th power. That's what it becomes. The difference of 2 powers again. Power is 4. But understand that?
Yes, sir.
Good. So it becomes equal to 2x minus 3. Note my value is 2x and minus 3. Bracket. First value is 2x cubed, but this and this must give up my first term. That's where I start. This is going to reduce and the 3 is going to increase. Next value is 2x squared times the 3. 3 start times the 3. You can put it in a bracket like this if you want. Plus 2x reduce and the 3 increase to a square. This done, and the 3 go to a cube. Do it as a process, not as a formula. And then you simplify. 2x minus 3 into, this is same as 8x cubed, 8x cubed. This is the same as 12x squared. This is 9 to is 18x. And this is 27. Right? That's it. I've factorized it to 2 factors. That's what I wanted. But to factorize it. Get 2 factors there. Right? It's a factorize a polynomial. Next one. Next one I gave is this. They gave 1000 minus 27 x to the 6th power. This can be raised to 3 cube and this can be raised to 10 cube. To get this to the cube, I'm going to write x squared cubed. So watch this now. I'm going to write this as 10 cubed. Sir, minus, yes?
What is stopping him?
Difference of 2 powers on the polynomials.
Oh, difference of
all
2
right?
powers and polynomials.
Difference of 2 powers and the polynomials topic. The last part of polynomials. But this was really the pure maths part. I didn't do it when we did polynomials. My intention was to do it one Sunday. I'm doing it now.
All right, then, sir.
And this can be written as 3x squared cubed. See that? This is 3x squared cubed. Because 3 cubed is 27, and the x squared cube is x to the 6th power. See that? So these are my values now. That's my A and that's my B. Ready? I'm difference of 2 cubed. This one easy. So I'm going to write 10 minus 3x squared into, I have to write 10 squared. 10 squared times 10 give me 10 cubed. And the power of 10 is reducing. The power of 10 reduces to 10. And then I'm introducing the 3x squared now. So I have 3x squared. The 10 done already. So I'm going to have 3x squared squared. Think of it as a process, not as a formula. 10 minus 3x squared, bracket. This becomes 100. This becomes 30x squared. And this becomes 9x to the 4th power. That's it. If you check it, this times this, I got equal that. If you check it. All right. I think there's one more. See, this no matter how many of them are doing, it's the same thing. Right? So I think how many more? I think there's one more there. All right. So it's not a long session, guys. It's a very short session just to go through this. Very easy stuff. We now have 27a cubed minus r to the 6th power. I don't want to factorize into 2 factors. Obviously, I'm going to use something cubed. So the a cubed there, and this can be written as 3 cubed. This now I write this as r squared cubed. So I'm going to write this as 3a all cubed minus r squared cubed, difference of 2 cubes, equals, this is my a, this is my b. So I'm going to get 3a minus r squared, bracket, 3a squared, because this times this, I have to give back the first term. Power of this reduces to 3a, and then the r squared start to arrive. This done, and my r squared is squared. Simplify. 3a minus r squared, bracket. This becomes 9a squared. this becomes 3ar squared, and it becomes r to the 4th power. That's it. If I multiply this times that, I get me minus r to the 6th power. If I multiply this times this, I get this. It is correct. If you expand it out, you're going to get back this. You're going to get a number of values eliminated each other. That is it. I've done all the questions. Right? We don't really set a lot. We know when we encounter the use, the difference of 2 powers, we're doing the topic differentiation from first principles. We have to differentiate from first principle, for example, x to the 4th power. We have to use the difference of 2 powers then. Yes. That's why we're going to encounter it and have to use it. A couple of the polynomials questions might have it, but if you notice, the polynomials questions that we did on past papers, you don't get a lot of questions with difference of 2 powers to apply. It's not a very frequent stuff thing on exam papers, but it's a part of the syllabus. You have to know it. And there are some multiple choice questions that use especially one that I showed you. They then give you 3a to the 5th power plus 4b to the 5th power to factorize. This now you have to use the difference of 2 powers because the powers are odd. You can apply the difference of 2 powers to it. So you maybe go like this. That's all right. Write it as 3a to the 5th power minus negative 4b to the 5th power. Got a minus make that a plus. Then you run with it now. So you get the 3a minus the 4b, or minus the minus 4b minus negative 4b. Your term becomes minus 4b in the second term, which in this becomes a plus times. Ready now? All right, the 3a to the power 4. As this time, this must give away a start. And my second value is now minus 4b, you know. So this reducing a minus 4b start. So come up. So you get plus 3a cubed minus 4b plus 3a squared minus 4b squared plus, put it here, so plus 3a minus 4b cubed plus minus 4b to the 4th power. Then it becomes 3a plus 4b. Because minus is a plus. Bracket. They're doing this one. That's 81. 81 a to the 4th power. And this is 27 times 4, but it's now minus. So you get 27 times 4. Which is that? 27 times 4 is 108. Is that correct? Yep, 108. 108 a cubed b, and then get back a plus. This is now 9 times 16. 9 times 16. That's 144. So you get 144 a squared b squared. They get back a minus. So I'm give it back a minus. Minus, you're going to get 4 cubed, which is 64 times 3. All right? So I get 192. 192 a b cubed. The last one is a plus 4 to the 4th power. That's 16 times 16 is 256. 256 b to the 4th power. That's what you will get. You get something like this. Well, something like this. All right. Well, that's it, guys. Just need to practice. What I'll do, I'll forward. I'll send the sheet with the questions from Shade to the group, so you guys can try the questions yourself. Same questions. All right. And the session is. Did I record the session? No, record it, you know? Did I record it?
You did. So you recorded it?
I did record it. It's recording.
Yes. Yes, sir.
Oh, cool. All right. Hey. All right. So what I'll do, I'll send the questions to the group. I'll do it right now, so that you guys can have it to practice from. All right. And that's it. That's a short pick and short session for the day. You all right, better, Shadi?
Yes, sir. Much better.
Yeah, so don't do it as a formula. Forget about the formula. Think of the process. The power of the first value coming down, the power of the second value going up. All right? And it's easy because you know where to start. You know where to start. And always the first value minus the second value to start, I know what power to start with. The power of the first value going down, the power of the second value going up. Until you're done, that's it. Regardless of the number of terms. And you're adding all the values on the second bracket are adding after you do the A minus B. It starts with the PERC difference of two squares right here. This is C set. That's where it starts. See, all the values adding. Adding is supposed to be a plus. I erase something on this. But so you go. I erase something on this. It's supposed to be a squared B plus AB squared. Alright, so you know all the values adding down here. But that's it, guys. That's it. That's what I wanted to show you. The difference of two powers. Quick and easy, nice and fast. Less than half an hour. Alright. So let me send this to the group. Did I send it? Yes. So you guys can use it as revision, and I'll send the video when I get it. So at least you can see the process again. Okay?
Yes,
So remember, class tomorrow, I can't tell exactly what time it's class tomorrow. Might be sometime in the evening, but tomorrow we're gonna have a class. We're gonna do the mathematical proof. We're gonna practice some mathematical proof questions tomorrow. All right, that is the plan. Let's practice some of the questions tomorrow. All right, bye. All right, bye-bye.